Hello and good day. It is Thursday, April 27th, 11:30 here in Toronto, where I'm based. My name is Angela Carnwright. I am Senior Manager of Digital Sales Enablement with Thermo Fisher. I work here on the marketing team, and we're here to present some best practices for you today under our Lab Talk series. So welcome. It's our second episode. The topic today is on biosafety. So we want to talk a little bit about when to upgrade your Class II A2 Biosafety Cabinet. I'm so pleased to announce our presenter today is Dr. David Phillips. He is our Senior Global Product Technology Specialist for Clean Air here at Thermo Fisher Scientific. I'm going to hand it over to Dave to kick off our presentation for Lab Talk on this Thursday, April 27th.
Thanks, Angela, and hello, everyone. So how long is a BSC supposed to last? The most official answer comes from NSF ANSI 49, a global standard for Class II biosafety cabinet design and performance, which states the current lifespan of a BSC is approximately 15 years. But there's a lot of older BSCs out there. In most cases, biosafety cabinets do not signal when it's time to move on. For the user, they just flip the switch, the fans come on, the lights light up, and they sit down and they work. So why should they replace it? The BSC replacement has two elements to it. First, BSCs do not just stop working. They work less and less effectively, kind of like pizza. Yes, it's great when it's still warm, but a couple hours later and the party's still going and you're a little hungry, you might have another slice. And then in university, when you come out of your room in the morning and there's still a slight slice remaining, even then it might not be too late. Another factor is that BSCs are improving every year. So rather than, is it still working like it did when I bought it? Maybe we should ask, how is it working compared to BSCs being provided today? You could have a perfectly restored Model T, but I don't know if we would want to take children in it on a drive through rush hour or on slippery streets. So how have BSCs changed in the last 15 years? There are three main categories for how a new cabinet may be more desirable than an existing biosafety cabinet. First, and maybe surprising to some, energy efficiency. There's been a revolution in improved energy efficiency in biosafety cabinets. Most of the cabinets of 15 years ago used a very inefficient type of electric motor. The average consumption was about 660 watts of the most common size versus cabinets like ours today with consumption down to 180 watts, less than a third as much. Most new DC fans can do things we couldn't do before in a cabinet. For example, we can close the window and the fans go to a reduced flow standby mode that draws even less electricity. Let's take one of the worst cases from the old days where the cabinet was kind of an energy hog and the laboratory followed some recommendations at the time, which was to leave the cabinet on 24/7. If we replace that cabinet with a modern unit with available standby and used it in the same way, we could save over $1,700 per year. As a side note, this sort of energy efficiency doesn't only save money, it's good for the environment. In the example I just gave, in addition to the monetary savings, it's also responsible for 9,500 less pounds, 4 to 300 less kilograms of CO2 emissions released every year, and there's a reduced heat load into the laboratory. Second, there are some interesting capabilities in current cabinets that provide greater safety, performance, and convenience. One I already mentioned is the reduced flow standby mode. As you know, the barrier that keeps the airborne biological hazards in the cabinet and the airborne room contamination out of the out of the cabinet is from the balance of inflow air and downflow air at the front opening. It's a wonderful thing, but that balance is somewhat sensitive. The air velocities are just over a mile per hour. We need to be careful that the room air currents or even rapid arm movements don't disrupt the airflow patterns too much. When you're sitting at the cabinet, because you're sitting there, most people don't get right next to you. But if you need to step away for a couple minutes or more to take a call or something, with new cabinets, instead of just leaving the cabinet with the front opening exposed to people walking by and whatever, you can close the window and there continues to be super clean, filtered, unidirectional air flowing down through the work area. When you return, just open the window and resume. The old cabinets really couldn't do that. Two other capabilities are user modified pass-throughs. Ours is called SmartPort. These are contained passageways for hoses, cables, and cords between the BSC work area and the room. In the old days, we'd see all sorts of hoses and such hanging out the front of the cabinet, which made closing the window impossible. User modified pass-throughs give a way to do this without obstructing the front opening. Another new feature for our cabinets makes it easier to do the required surface decontamination of the BSC sample chamber. We're supposed to wipe down all the sides and the work surface. Our Smart Clean, which we'll see in a few minutes, makes it easier to get to the upper portion. The third category of reasons to upgrade or replace your biosafety cabinet is new requirements for what you're doing. These can be connecting to exhaust to allow for the use of volatile toxic chemicals, or perhaps even more rigorous monitoring requirements that we find in cell and gene therapy or even use in GMP environments. Let's take a look at the cabinets in our immersive lab to get a better understanding of some of these things. We have our Thermo Scientific HairSafe 2030i on the left and the 1300 series A2 on the right. They're both Class II Type A2 BSCs under NSF ANSI 49. Both are available in versions meeting the European standard EN 12469 or the NSF 49. The European 1300 series is called the MSC Advantage. I mentioned reduced flow or standby using the 1300 A2 MSC Advantage as an example. See how we can just close the window. Good. There's a momentary beep as the window is moved out of position, but it stops when the window is closed. Now, we don't have a potential turbulence problems at the front window from people walking by, and as I mentioned, it's drawing even less than half of the already low energy requirement for normal operation. This is great for when you just step away. Now, I want to show you something cool. It's critical to wipe down the interior of the cabinet work area. This cabinet has a neat feature we call Smart Clean, where you just pull the window down past the front opening, which opens a gap at the top, where it's much easier to reach in and wipe down the upper portion of the work area and inside the front glass. While this is happening, there's inflow through that top opening, helping to prevent any dislodged contamination from escaping. Pretty nice. Let's close that up and then let's look at our HairSafe 2030i. It has a motorized window as well as transparent side walls. We can't lower the window beyond the closed position, but it does have a feature of great importance to some applications. The window frame can be raised, giving access to the entirety of the cabinet work area from top to bottom and right to left. For applications using complex equipment inside the cabinet, it can sometimes be tricky to fit everything in through the front window and connect everything even when it's raised. But this feature gives that full access. We call it Smart Clean Plus, and it provides ultimate access to the work area. While the cabinet is opened up, let's take a closer look at the interior. The smart port, see the larger gray plastic circle, uh, that's the user modified pass-through we call smart port. We have one on each side, and it's what allows that passage of cables and hoses and such through a negatively pressurized containment zone to prevent migration of contaminants from inside out or outside in. Now, the HairSafe 2030i has a lot of new features associated with the touchscreen, but my favorite is auto start and auto stop, so much so that I've asked them to do a neato cool demonstration. So the cabinet's off right now. And so Maggie's going to get us started. So she just simply presses and holds the auto start. And then once it starts, steps away, and you'll notice the motorized window is coming up to the operating height. The internal light comes on, and the fans come up to speed. It's important to remember that even as we look to meet the needs for ever more demanding applications like we've talked about, it's important to remember that for many users, they simply want a clean and contained work area without all the bells and whistles. Auto start and auto stop is for all the people who just want two things from their cabinet. They want to turn it on and they want to turn it off. These are configurable startup and shutdown sequences you can set up however you want. You could go through the entire 15-year life of the cabinet and only press those two keys. In addition to simplifying the cabinet, the touchscreen does two other wonderful things. First, it clearly communicates how the cabinet is working. This is still in startup mode. You see you have a yellow triangle at the top showing that the cabinet's not quite ready for use. It just became ready. So notice the green heart. It gives, you just look at one place and you can see that everything is working fine. If there's an alarm for airflow problems or window position issues, in addition to audible and visual signals, this cabinet will show a ticker display in the user selected language explaining what is happening. Using downflow as an example, the ticker will explain that low downflow could allow for more contamination to reach the work area, so our samples could be protected and we should call for service. So our samples could be contaminated and we should call for service. Like all our cabinets, these cabinets work hard to maintain the necessary airflows and balance at the front opening. But if there is a problem, this cabinet has made great improvements to clearly communicate this and explain. In the old days, the cabinet just cried like a baby, and like a baby, you had to guess what was wrong. Well, our baby's grown up. With full text alarm and alert messaging, this cabinet has a downloadable event log and volt-free contacts to signal containment, making this cabinet well suited for use within GMP and cell and gene therapy processes. Now, both these cabinets are Class II Type A2 Biosafety cabinets and listed to NSF ANSI 49 or EN 12469 by TÜV Nord or LNE. As such, we can vent the super clean filtered exhaust into the laboratory or room, which is the most common application. Or if we're working with volatile toxic chemicals, which like air will pass through the filters, we can connect these cabinets to an external exhaust system, kind of like we would for a chemical fume hood or a laboratory cupboard. We would connect this to an exhaust system with what's called a thimble or canopy transition. Transition to describe its role as a connecting device between the cabinet and the exhaust duct. The thing about a thimble is the gap. When most people first look at it, they think, oh no, I have a leak in the exhaust. Well, it is more accurate to think of it like a little fume hood up there. And oh, look, Dr. Roberts here has decided to capitalize on this and is working safely, knowing that any fumes from her work are being drawn into the thimble through the gap. The building or external exhaust system pulls more air than is produced by the cabinet. The balance is pulled through the gap. This particular location is our little demonstration lab, so we don't have an external exhaust connection yet, but we can see the round opening on top of the thimble where the 8-inch or 20-centimeter diameter duct would be connected. I'll make a note to update Dr. Roberts that it's not connected yet. So what's good about this? The thing about shared exhaust system where the cabinet is connected to the same system a lot of other devices are connected to is that there's constant variation. Sometimes a little, sometimes a lot, but it varies. The draw from our cabinet could increase or decrease depending on if somebody starts or stops using their fume hood next door. Many labs are negatively pressurized. When we open the door to go into the lab, the exhaust pulling into the lab increases as the open door removes some of the resistance. When the door closes, it goes back. These and many more things are constantly changing, and so there's constant bouncing or variation in the exhaust. A traditional direct non-gapped connection would have the cabinet inflow velocity bouncing right along with it. If the cabinet cannot exhaust as much, it doesn't inflow as much and containment might be affected. If the exhaust suddenly jumps up, so does inflow and room contamination might be drawn into the cabinet. The gap, Dr. Roberts' fume hood, acts as a sort of shock absorber. If the external exhaust decreases, the BSC exhaust stays the same, as the cabinet fans are just pushing air into the thimble, so the inflow velocity at the gap is the only place that sees variation. Still enough to contain, just not as much. If the exhaust system increases, just more is pulled through the gap. We don't need that balance of inflow and downflow at that gap as we do in the front opening of the cabinet, so we just let that gap handle the variation. So if our needs require us to add external exhaust, depending on the age of the cabinet and the availability of the transition pieces, it might be a good time to upgrade and include the necessary exhaust transitions. So we hope this has been helpful. Class 2 BSCs are wonderful devices, and even though they appear to last for a long time, but as we look at knowledgeable recommendations, improvements in energy, current features, and our own changing requirements, even though we could keep using them, maybe we shouldn't. And that's our presentation for today. Thank you.